Alright, time to now discuss our favorite subject, or not really mine, but basically it's a bit of a refresher from high school. Chemistry. Chemistry. So, I'm going to form a little table here, and you can go ahead and keep up with it. We're, of course, in chemistry we start with atoms. And they have well, really I shouldn't put atoms here as a title. We're going to have generic titles here of the subatomic particles inside the atom, which is the proton, the neutron, and if I misspell neutron, sue me. And we're going to also have electrons. Okay. Alright, so here, each of these, of course, are associated with a charge. So, protons have what type of charge? A positive one. And from electrons, I'm not really bothering with mnemonics or hints because this is very essentially basic. So electrons have a negative charge. Now with neutrons, they have neither charge, so we say that is a neutral charge. And if I misspelled this again, you know what to do. So what's particularly interesting, and what's going to come back later, is the mass of these particles. Now, the mass of protons and neutrons, which is very interesting, is 1/2 of the atomic mass. So understand that this is mostly mass here. And it's the same thing for the neutron, and this is a not a paraphrase, but well, I forgot that word that I use half the time. But basically it means to go down like that. Anyway, so the protons and neutrons have basically make up the mass of the atom. When you look at it, if you look at a picture of it, you have this centerpiece with the neutrons. Let me draw a little arrow there. With the neutrons and the protons in there. So just anyway. So that is where all the mass is, and think of it as a central point with no real volume to it, just like a single little pixel, if you will. So what does this mean in terms of volume? And remember the difference between mass and volume. And think of mass as a type of weight, or the density of something, how much it contains of this or that. Volume is actually how much space it makes up. Doesn't mean that has a lot of mass to it. You know, think about a balloon in a sense. So this virtually has no volume. No volume. It doesn't take up any space at all. No volume again. Alright, but surrounding it is the electron cloud, and you know, you got the various shapes, but again, I'm not going to go into that. Haven't reviewed that for years, but essentially the surrounding cloud, electron cloud, if you will, let me put E here, is basically what takes up the most volume. Well, actually, technically it's the space between that and the electron, but the electrons that are taking up the volume, in the end, that's what it is. But they virtually have zero mass. Zero mass. Alright, so that's a good little review on the little atoms. So that's eaten up about 5 minutes. So let's get into more of the technical terms, I guess. We have, let's see, so again we were talking about atomic mass. Atomic mass. And that is essentially protons plus neutrons. When you think about it, protons half the mass, neutrons half the mass, and together they make up the atomic mass. So that's fine. And that's with normal atoms. You get different things with ions and isotopes and whatnot, but I mean, essentially, we'll look at that later on. Now we also have the atomic number. Now what's the atomic number? Well, actually, let me just bring that down. So that's atomic number. That's the amount of protons it has. Or really, you would say the amount of protons and neutrons, because protons and neutrons equal each other. Which brings us to the next basic fundamental rule when dealing with normal atoms, is that protons equal the amount of neutrons, which equal the amount of electrons. Alright, keeping in mind the charges. Alright, so here let's go ahead and also discuss basically the way an atom looks. So if we're dealing with atomic number of 8, so protons 8, neutrons 8, so that is our nucleus of the atom, not the cell, don't confuse the two. So if you have 8 electrons, the first 2 are in this innermost shell, and I could just put them up here on top. So and recall there's something called a valence shell. Valence shell. Let me spell that out. Valence shell, which is the outermost shell. And recall that atoms, after this inner layer of 2, it continues building these layers of basically octal layers, layers of 8. You have 8 electrons surrounding the entire atom, going around in a kind of compass, if you will. So let's take a look at that. So if I'm adding 8 electrons, I've already added 2 here. Now I'm in the next shell, because the initial shell only has 2 and the next one's going to have 8. So we do 1, 2, 3, 4. Alright, so that's 2 plus 4, 6 so far. Now we need to add 2 more. 1, 2. And we have an empty space here and an empty space here, essentially. So this right now, let me go ahead and highlight this, is the valence shell. That is the valence shell, what I just highlighted there. So with this valence shell, this is where most of the interactions are going to occur in terms of trading an atom. And I'll put like a link in the sidebar. YouTube's weird now, sometimes the sidebar is there. The description box, I should say. It's there or there, but in any case. So how would atoms interact like this? Well, if you recall, I'm trying to pull out my notes here. You have these types of bonds, and I'll discuss what the types of bonds that you have in a future video. How much time do I have left? In fact, let me focus the entire next video on that subject. So this video basically took you through atoms, their charges, what the atomic number is. So 8 protons, which is the atomic number, you can say abbreviated. That's the word I was looking for earlier. So ATO is abbreviated as atomic number, which here happens to be 8, and it's 8 protons, 8 neutrons, 8 electrons, because they all equal each other, and it takes this form. And the outer valence shell, if you will, has 6 electrons in it. 1, 2, 3, 4, 5, 6. And the innermost shell has 2 electrons in it with the nucleus. So anyway, let me go ahead and end this show, and I'll see you in the next video.